In this tutorial, I'm going to break down all the steps you need to know for how to create your own modular railing set using Maya and then taking them into UE5 to use. This is exactly what I did to create this 6-piece railing set that you may have seen me using. And I'm actually going to create these from scratch so you can see how they were done. And you will pick up a lot of tips on modular creation and you will know how to create your own modular railing pieces. We will create 6 pieces total, a straight piece, then a straight half piece, 2 connector pieces, a 90 degree and 180 degree, a railing that will go up the stairs, and an end cap. And then from these, you will be able to expand and either add more detail into them or create more variations within the same modular set. If you don't want to go through and create these yourself, then you can actually download the 6-piece modular railing set from WOLD Patreon. Just simply become a WOLD Patreon supporter and you'll get these assets and more to use within your environments. So in this tutorial, we'll cover the entire process from modeling to UVing to exporting and importing to texturing, creating material, setting up collisions, and then using them inside UE5. And that is the complete workflow you need for creating modular railings. So let's begin. First, very briefly, let me cover the scene setup. I have a scale box reference that is 180 centimeters in height, as well as a UE4 mannequin imported into the scene to help me judge scale, dimensions, and proportion. And I use these all the time in every scene. And I have a tutorial on how to export one of these out of UE4 or UE5 and then import it into your Maya scene to use. And then my grid size is set up to match UE5. And here's my settings. If you go to display, grid, options, here are the settings that I'm using. And these values match the 10 unit grid system, 10 unit grid snapping in UE5 or UE4. And this is the most important part of creating modular assets, or any assets for that matter, is having your grid set up so you can snap and make sure you're creating everything on the grid, as well as to correct dimensions and scale. And I also have a tutorial that goes more into depth about setting this up and everything you need to know about it. Now let's create our very first railing piece, which is going to be railing 300 in width. And this will be the standard for which we will create the rest of the pieces. Now, because modular railing relies on the environment, on the floor, on the walls, on the ceiling, and the staircase within your environment, we need some kind of modular architecture pieces to match these railings too. So very quickly, I'm going to create a floor piece, a standard floor piece that I use for modular environment assets. And it's going to be a simple cube, and width is going to be 300, height is going to be 20, and depth is going to be 300. So this is the standard floor piece that I use. And our railing, the first initial railing, is going to match so you can fit the floor piece. So if your floor piece or your wall pieces are bigger or smaller than that, then you need to match your railing pieces to your modular environment architecture kit. So this is why I'm going to create our first piece at 300 in width, so it matches the floor and the wall. So this is our floor piece. So I'm going to use this as a template to help me create all the modular railings. And then let's also create a wall. And this wall is going to be also 300, but it's going to be standing vertical. So width is going to be 300, height 300, and depth at 20. Again, these are the standard wall sizes that I use for most of the modular architecture environments. These are kind of like the standard that I go with and start with. And let me reposition the pivot point. So here we have the floor and the wall, and we'll be able to create our railing set to match these architecture pieces. Now let's create our first railing. The first thing you need to do is decide on the size of the cylindrical piece. So let's create a cylinder. Let's get a little closer and start inputting values into the inputs. I don't like to scale things because I need to know the numbers that I'm using. So if I need to recreate another railing piece and I don't want to duplicate, I know what I used before so I can recreate it again. And it just helps to know these values ahead of time so you can replicate them later if you need it. So for height baseline, this simply places the mesh on top of the grid. I'm going to set it to -1. Now next, for radius, I'm going to use a radius of 3 units, 3 centimeters. This is pretty good size. And actually, let me move this wall out of the way so we can see our scale reference next to this cylinder. For the height that I want is going to be at 100. I already have these values picked out, so I'm just simply inputting them. But the way I found them is by inputting these values in here and judging my proportion, my scale of these railings next to the human scale reference. So the radius is going to be 3 units, height is going to be 100 units or 100 centimeters, and of course width is going to be 300 units so it can match our floor on our wall. But the height of this, if I go into front view, you can see that it will match and reach about waist level, which is pretty good height for most standard railings. And last, for subdivision axes, I'm going to keep it at 20. I like cylindrical numbers that are divisible by 4. So 16 is good, 20 is good, 24 is good, or 32. I'm going to use 20. So this is our standard size for the railing. Let's go ahead and block this out first. So I created our initial cylindrical shape, and I like the size, I like the height. And now let's block out the rest of the initial railing. So I'm not modeling yet. I just want to block things out to see where the pieces need to go and how it's going to look compared to our scale reference. I'm going to make a duplicate of this, Control D, and rotate it 90 degrees. This is going to be a horizontal piece, and I'm going to move it up and snap it right there on the corner or right on the grid. Eventually we'll move this piece more in, but right now we're just blocking things out. So for the size of this, I want to reach 300 units across so it covers the entire floor piece as well as walls for my architecture, for my modular assets. So it's going to be 300 units long. So I simply went ahead and snapped my vertices all the way to the other side, and I'm using the floor to match so I know where to snap these two. And actually what I wanted to do, I wanted to keep the inputs so I can adjust one value for the cylinder and make it smaller when we reach a certain portion. So a way to duplicate while keeping the inputs for all the duplicated pieces, because right now I simply duplicated pressing Control D and I don't have my inputs anymore. If I wanted to keep my inputs to make further adjustments and modify some of those values, let me delete it and do it again. Select the original piece, the one that has the inputs for you to adjust, and you need to go to Edit and Duplicate Special. Let's go to Options. The shortcut key is Control-Shift-D. And the setting that you need to make sure it's on is Duplicate Input Graph. And every time you press Control-Shift-D, you will get an input available for every duplicated piece. Let me go ahead and close. I'm going to press Control-Shift-D. And now I can go ahead and rotate. Hold J, rotate, snap. And I will have access to my inputs if I need it. Now let me go ahead and just resize it, scale it, move these vertices to the other side at 300 units. So this is the height, this is the top of the railing. Let's make a duplicate, Control-Shift-D, and move it down. And I'm snapping these to the grid to make my construction, my modular construction easier, and I'll be able to replicate the same snap and the same alignment and position of these railings for anything else that I need. That way, everything will match in its position. So here are my two railing set for horizontal railing. Next, I need two pieces for the inside right here. I need one, and then I will need a second one. Now I want to make sure that these are centered and they are equal distance from each other. I could eyeball it, but I want to be more precise with these. So I'm going to create a cube, a temporary cube, and I'm going to set the size of this 300 in width, height 100, and depth 20. And I just need a couple of subdivision axes equal distance from each other by adding subdivision width, and let's add 4. This will give me 3 edges in the center, but most importantly, if I move it and cover the entire distance of the railing as well as the floor, it gives me guidelines for these edges and they're equal distance from each other. So if I take this piece and I snap it to the grid, or I can actually snap it to this line, to the edge right here, by activating the Z-axis, so it's yellow, left clicking on it, and then if I press C and the middle mouse click and drag on this edge, it'll snap to the center at its pivot point. So this is where I want to keep this railing, because again, I want to make sure that these are equal distance from each other, so when I duplicate the entire railing piece and continue the 300 piece across, everything will be even and exactly the same. Now, one thing to note, let me move this template temporarily out. The size of the cylinder right now is at 3 units, the radius, same as for the horizontal pieces. However, when you take a look at this, there might be slight overlap or Z flickering, Z axis fighting due to the overlap and how this piece right here on the edges is overlapping with these faces right here. And you might get some problems right here for this railing piece. So the horizontal and the vertical pieces may have some flickering due to the same size and the overlap that they have. Now, I don't want to have these pieces be combined together into a seamless model where I have to model these pieces in as they would be welded together. I could, but that takes a long time and overlap is completely fine. The only thing is I want to avoid the flickering. So I will just simply take the vertical pieces and lower them in size to 2.8. Maybe 2.9, 2.7 could work, but just slightly lowering in a few units will remove the possibility of that flickering going on. You can see right here, it got smaller in size, so I'm not gonna have those faces that are on top of each other flickering. Now again, your other option is to weld it together and actually model those pieces so they are welded together as one single model instead of two pieces sitting on top of each other and overlapping. That's one option. Another option is to create an additional piece. For example, this is just a quick little option you could use, is you would introduce a whole new brand piece of geometry. Let's say maybe a cube, could be a cylinder, and let me snap it right there just so I can show you, and essentially create an additional piece of geometry that would hide whatever overlap you have, like so, kind of like a welded piece that keeps these two railings together. And then you can model more detail into this. You can maybe bevel the corners, so something like that. Again, you can introduce a cylinder. Maybe you can even create few cuts into these cylinders and then extrude those faces out, so you have more detail on the pieces of geometry where the two railings overlap. I'm going to keep it as is by simply lowering the radius to avoid that overlap, but you have some flexibility that you could add. Now that we dealt with that issue, let me go ahead and bring that back a little closer. And I want to take this railing and duplicate it for this edge right here. So I'll just simply duplicate this time because I don't need to adjust any values here anymore. And I'm just going to snap it to this edge. Make sure my axis on X, left to right, is highlighted. I'm going to hold down C, middle mouse click and drag on this edge, and then we'll snap right to it. So now these are equal distance from each other. So when we have our railing piece, which would be this right here, this is our first through-handle railing piece. We're not done yet. We need to work on it more, but this is the size of our railing. So when we take this and we duplicate it and simply move it, it will snap to an existing railing piece right next to it. And the distance right here in between will be the same as in between these two railings in the center. So that's why I had to bring that box with a couple of subdivision axes in there, so I know that equal distance that the railings must have. All right, let me go ahead and delete this, and I no longer need this piece, that template. Now let's do some quick cleanup and create our first usable modular railing piece. I'm gonna select everything, Control 1 to isolate select, just so we only get to see whatever we are working with. And I need to delete the faces that are not going to be seen by the player. So these right here on the end corners, if you need them for any reason and you're going to leave your geometry exposed to the player or to the camera, then you may want to leave these faces. I do not, so I'm going to delete them. And I'm going to do this for all of these cylinders. We will create an end cap and an end piece to close these up when we have them on the corners or on the ends. Otherwise, we'll use other pieces, other railings to continue our modular creation of these railings. So you'll never see these faces on the end. So let me go ahead and switch to faces component mode. And for quicker selection, I'm going to select the faces I do not want to delete. It leaves all the faces unselected. The ones I do want to delete, hold Shift, left click, hold and drag to invert my selection and hit delete. And I'm going to do the same thing here. Select the faces, hold Shift, more key drag to invert my selection, delete. And also do the same thing here. Very quick way to delete faces instead of having to select them, fly my camera in them, make sure I select them all. Inverting your selection can often be faster. Alright, we cleaned it up. I'm going to select everything and let's combine. I'm going to hold down Shift, right click hold, choose combine. And now, very important, because we were working on the grid and everything was being snapped to the grid. This is the position that you want for your modular railing. When you combine, it centers the pivot on an object. This is not the pivot you want. You want the pivot to be somewhere else. And for this piece, I want this pivot to be right here on an edge, on the corner, right exactly where the floor is. And it happens to be also in world origin, which is going to be useful for later. But for this railing piece, I want the pivot to be right here on the corner. So when we duplicate, we can easily snap this railing to another railing and expand on it. You could also snap your pivot point here in the bottom in the center, but you do not want to keep the pivot point in the middle of your object as it is now. You could make it work, but it's not very modular friendly. So I'm going to hold on DX so I can snap my pivot point, modify it, and snap it to the grid. Middle mouse click and drag, and snap it into the corner right here. So here's our pivot point. The edges of these cylinders all align to the corners. It is 300 units in width. it matches to the other side, also matches to our floor. The pivot point is exactly here on the bottom. So if I take this and I duplicate it, hold X to snap to the grid and test to see if the modularity does work. And if there's no overlap, it will be flush next to the other piece. And this is exactly what you want. So I can just continue creating more of these across and they will snap to each other. And then when you have the floor, because these two pieces match, the floor can also be duplicated across and it will match the railing. This is exactly what you want. So we have our first modular 300 railing piece. Last thing I'm gonna do for this piece is make sure I delete history and name it. Let's name it railing underscore straight underscore 300 to signify the size of it, because we will create a 150 piece, which is half the size of this. The half piece needs to be half the size of 300, which is 150. And we can easily create this 150 half piece from the 300 by introducing a halfway point, a cut, and then deleting one side, the right side. Thus keeping the same pivot point, and the distance of this railing, the vertical one, will be equal distance if we need to add this 150 piece to 300. So it will look seamless. So these two vertical railings, the way we place them, works in our favor for the 150 piece. So there's not much repositioning and alignment we'll have to do. So I'm gonna take the 300 piece. Let's move it off to the side actually. And I'm gonna make a duplicate of it and bring back the duplicate in the center right here in our working space. And let's introduce a cut right here in the center. To make sure the measurements are correct, I can introduce a 150 floor or a wall just so we gauge the width correctly. So let me introduce a new cube. Height baseline -1, so it's on top of the grid. Width 150, height, let's do 300, and depth at 20. Again, this would be the standard size of a half wall. So we would have a 300 wall and then a 150 wall. And they would match and be seamless next to each other for those spaces that we need slightly smaller. Let me go ahead and reposition the pivot point so I can snap this right here. And now let's introduce that cut. And I use the modeling toolkit and multi-cut, hold down Control, and then middle mouse click anywhere. And middle mouse click will place a cut in the center of the horizontal beams. Let's do the same thing here. Control, middle mouse click. And then I can select the faces on the right hand side and delete them. And we have a half piece. And it will align with the wall. Let me bring the wall forward. Like so I can see better. And we have perfect alignment for this 150 piece. And if I need to take this, and let's say we snap it just to test, and you want to test this inside Maya all the time, the modularity of your assets. I'm going to make a copy of this 150 piece. And let's snap it to the grid, and next to our 300 piece, make sure that this is also snapped to the grid. And you can see that it's seamless. I can actually just continue 150 piece indefinitely just to see how they are repeating. And the distance is perfect. It looks like we have multiple 300 pieces. And that's what I wanted. I wanted to make sure that the 150 piece has that same distance for the vertical railing. So let me take this wall back, just move it back. And we have a 150 piece. So once you have one modular railing created and you have your cylindrical width and the depth and height and everything already positioned how you want it, creating additional pieces from an existing base piece is going to be a lot faster. And that's what we did here. The pivot point for this is going to remain in the same exact point and the same exact spot as it is for the 300 piece. And the last thing we need to do is rename it. Let's delete history first and then name it to railing straight, and this is going to be 150. And we have our second modular railing, the half piece. Next up we need to create is the railing that will be going up the stairs. So this way you can expand to go to the upper floors or lower floors and have a lot more versatility with your modular railing kit. For this, we do need a set of stairs to make sure we match everything and it aligns to those stairs. So I'm going to create a set of stairs, a standard modular set of stairs that I often use, that we can match our railing to. And the railing will be aligned in position to it. So I'm going to create a 150 height set of stairs, which can be reused and duplicated to go up to 300. Because our height for the walls is 300, that's what the stairs need to go up to. Instead of creating 300 height for stairs, I often create a half piece for 150. It allows me to have that half floor point, or I can just reuse and have two of them to go up to 300. I'm going to create a cube and let's set height baseline to -1, so it's on top of the grid. And let me move this right here It's going to be aligned to the floor. It's going to help us to create the modular railing going up and just make sure everything is going to be aligned between the pieces. So I'm simply going to snap this cube right here temporarily, and then we'll align it next to the floor. The width is going to be 30. Well, actually, this is going to be depth, since we're going to be creating single step this way right here. So it's going to be input into the width, but this is depth for the step. And the good depth for a standard step is 30 units, 30 centimeters. Height, good standard height is 15 units. And then depth, which is in our case width, is going to be at 300. Let me reposition the pivot point right here in the corner on the front, and I'm going to snap it to the grid and to the floor right there. So this is our single step. Now, it doesn't mean that you cannot create your steps with different dimensions. You often will. It all depends on the architecture style. I found that these dimensions right here are very good and look the best for standard set of stairs. But then you'll have to adjust it based on the architecture style and the environment you're creating and the dimensions that you will be using. So these will vary greatly. So you'll have to adjust them to what you need for your environment. And then once you have your steps and your stairs, then you will create the railing on the side of the stairs going up or going down. It'll be used interchangeably for your steps. So these are the dimensions that I'm using. So our railing is going to match to these steps. Now we need 10 steps to go up to 150 units in height, the halfway point. Because our step height is 15, we need 10 steps. 15 times 10 is 150. And let's go ahead and duplicate it. I'm actually going to modify the pivot point to be in this corner on this vertex. Then I'm going to press Ctrl D to duplicate. I'm going to snap this step to the second step right here in the corner, right to that vertex. And then with it selected, because I already duplicated and moved it, I will use Shift D to duplicate with transform. And it will position all additional steps in the same exact spot going up in the amount that I moved it. So here's 3, 4, 5, 6, 7, 8, 9, 10. And we have our steps. I can bring back the half wall and just test it to make sure that everything is aligned. And we need to actually increase the width to 300 instead of 150. And then let's lower the height to 150 because I want to test the height as well. Let me modify the pivot point and just place it right there. And make sure that it is aligned, and it is. So the steps are going to the second floor to 150 units. There's 10 steps and their depth, or the amount of units that are going up, is 300. So I can duplicate this floor just to test, and everything will be aligned, as you can see. So this is what will help to create our modular railing that's going to go up or go down the steps and align with architecture geometry as well as with other railings. Let me go ahead and delete this. I can move this back. And I'm going to combine these steps. Shift, right click hold, combine, and let's modify the pivot point to be right there in the corner. So this is our template, and now we can go ahead and create the incline or the decline railing for the stairs. So for this railing piece, we're also going to create a 150. So it's going to expand the amount of units, the same for the stairs. So the railing will be 300 going up to 150 height, the same as for the stairs. And then if we need to go up and continue these stairs as well as the railing to 300 and make it continuous in order to reach the second floor, we can just reuse the steps as well as reuse the railing, and they will snap to each other. So we can go ahead and go all the way up. That's allowing us a little bit more versatility with our kit. So we can have 150 railing in height or all the way to 300 by just doubling them and placing them next to each other. So this is what we're going to create. We're going to create a 150 going up, and it can be reused to go up to 300 or even higher. Now I'm going to create my layout right here for the floor and for the stairs. So they're aligned and they go up to 150. This way we know where to place our railing, so we can go ahead and bridge this and create in-between area for our railing going up. I'm gonna take the floor and duplicate it and position it right there next to the stairs. So we have our first floor and we have our half piece, or the half floor going up at 150. Then I'm gonna take the 300 piece, the railing itself. I'm gonna make a duplicate of it. This is going to be a throwaway, but we need to adjust it and make a position where these railings will start. So I'm going to position them right there in the corner, like so. And actually, let's go ahead and move slightly, because I want to keep these in the same exact position as we created the ones before. So I'm going to keep the pivot point right there and the alignment to be on this line right like so. So I just want to move the floor slightly 10 units over, as well as the steps, just so we can see the alignment and where they're going to be positioned. And then make sure that I have these aligned on top of the floor. All right, now I'm gonna make another duplicate of it and move them up to the halfway point, like so. And move them so they are aligned with the floor. Let me go to front view. And it's gonna be right there. And move it up. So now they're flush, sitting on top of the floor at 150 units. Same for the one on the first floor. So now we have a position. Let me actually move this also right there. So now we have the in-between area that we just need to bridge the gap and create the railing. And when we have our straight railing on the bottom, we have a straight railing at the top. Everything that's created in between will align to the straight railing. So we're using these two as a template to create the area in between. Now let's go ahead and take these two straight railings and we're going to combine them, because we need to bridge in between to create the in-between piece. I'm going to combine these two together. They need to be one. And again, I'm working on duplicate copies, so here's our original. Now with these, let's go to Model and Toolkit, and I'm going to bridge these areas in between. I'm going to select the edges right here. Since we don't have a face, I'm going to select the edges. And then I'm going to select the edges for the top one right here. Hold Shift, double click to add to a selection. Both set of edges on both of the cylinders are now selected, and I'm going to bridge. And they've been connected. I can take a look at the curve type. I'm going to keep it to linear, but I can maybe add blend. And actually that's not going to work for us. So we're going to keep it at linear with no segments added in between. All right, so we have one connection point made. And now let's go ahead and create a second one. Select these edges, also the ones on the other side. Make sure that I'm selecting correctly. Let me do it again. Now let me check that both sides are selected, and let's bridge. And now we have a second connection point. If you need to make a softer transition here, you might have to do this manually. The important part is keeping these edges and these faces right here in the exact same spot, because this is your straight railing. This is your angled railing. Everything that happens in between can be adjusted, but these connection points right here in the center, this edge, has to be exactly where it's at, because we're going to end up deleting these right here and these right here in order to leave us with the one railing that will be going up or down the stairs. So those connection points have to stay where they are. They cannot be moved. But everything that happens in between can be adjusted to whatever you want. So if you need to have a softer transition here, you can just insert a few edges, select that edge, and then maybe make adjustments to it so there's a smoother transition here. I'm going to keep it straight to keep the video moving along so I don't add too much detail into it. Let's delete what we don't need, so we are left with what we do need for the modular railing staircase piece. Let's go to faces. I'm going to select these on the right, delete, and these on the left, delete. And we are left exactly with what we need. I'm going to make sure that I leave them in the same exact spot. We're going to modify the pivot point later. Right now, we need to introduce the vertical railings. For this, I need one of these pieces, or I can recreate the existing cylinder we had with the same dimensions as before. So let's actually do that. I'm going to create a cylinder. Because we're working on the grid, I can go ahead and snap that cylinder right there. And let's adjust and input the settings we used before. This is why it's important to write down the values so you can recreate it anytime you need it. So our radius was at 3. In this case, these are vertical, so let's bring it back down to 2.8. Height, let's do 100. We'll modify it later. Height baseline, -1, so it's on top of the grid. And subdivisions at 20. And now let's bring it in position. So we need 2 vertical railings here. And if I need them to be equal distance from each other, I'm gonna reintroduce the cube with subdivision lines. In this case, I'm gonna duplicate the wall, Control-Shift-D, move it right there in the corner, and then introduce subdivision with 4 segments. So we have a line right here on the left, a line right here on the right, and that will give us equal distance from each other if we need to continue this railing going forward, or when we introduce a straight railing as we reach the second or the half floor. So I'm going to take the cylinder, the vertical pole, and I can snap it to the grid. And in this case, actually, I'm going to snap it to this line. So I'm going to activate the x-axis, so it's yellow. Hold C, middle mouse click and drag on the edge of the wall. We haven't moved it, it's still in the exact same position. It just moved it to align itself with this edge. And now I can move it up. In this case, I'm going to move it up and place it on top of the step. Now I want to go ahead and snap it because these would be the stairs that I'd be using inside UE5. So I want to make sure that the bottom of this railing is exactly on top of the step. So I'm going to activate the y-axis up and down, make sure it's yellow, and then I'm going to snap it down to an edge of the step. I'm going to hold down C, middle mouse click and drag on this edge, and then we'll snap it down flush with the step and not move it towards this edge. This is why you're activating specific axes, so it snaps along that axis only. And now we just need to adjust the stop. I'm going to do this later. Let's go ahead and do the same thing for this edge right here. I'm going to duplicate, Control D, move this railing. Actually, let's go ahead and snap it to this edge. I'm going to activate, that's the axis, so it's yellow, or the x-axis, so it's yellow. C, middle mouse click and drag on this edge, snapped, and now activate the Y. C, middle mouse click and drag on this edge. Now it's snapped on top of the step. I no longer need this wall. Let's go ahead and delete and adjust the tops so they are inside this railing right here. Let's go to front view. Gonna go to face component mode, or let's do vertex component mode, not faces, and move them in. And then I'm gonna fly inside this cylinder right there, and I'm just gonna lower it until it's completely inside the horizontal cylinders, and they are. And then just take a look so nothing is overlapping or showing through. And let's do the same thing for this. Let's go to front view, lower this in, and then into perspective view, fly inside the cylinder. And let's go to the top actually. And it looks pretty good, like so. Now, the faces that we have on the bottom and the top we don't need, so let's go ahead and delete them. I'm gonna select the faces. I'm gonna make a selection of the faces I want to keep, but then use Shift Marquee drag to invert my selection and then delete. And do the same thing for this. And here we are, we have our railing going up or going down the stairs. Let's combine everything. Select all the railing pieces. Shift right click hold, combine, and then snap the pivot point. Let me move the steps right here. Snap the pivot point on this edge right here. So essentially it would be, let me reintroduce this piece. Control D temporarily so I can snap it and just judge exactly where it would be. So the pivot point for the straight railing is right here on the bottom and on the grid. And then when it aligns flush with this, we need a pivot point to be along the same line. So both of these can be put together and they are seamless next to each other. So I'm going to hold down D, X, and snap my pivot point right there. So here's what we would have. So I would be able to use these railings going up as long as I have the stairs inside the level. And then I would just position these, snap them along the grid, and they would be flush with the steps going up to the second floor or to the half floor. Or if we decided that we want to go up to the full height of the floor instead of a halfway point, we can just take this, duplicate it, and then continue snapping on the grid, and it would be positioned right next to it, flush, like so. And then the steps would also be duplicated, like so, going all the way up. Actually, let me bring this down, right there. Flush with these, and you can see everything would be aligned correctly, properly, going all the way up to 300 units. And then we would have our floor right there, like so. And this is a good idea to do this inside Maya to test your modularity right here as I'm doing. And also let me go ahead and snap the other piece at the very top, duplicate it, and then position it on the grid, snap it to this railing to make sure everything is seamless and aligned. Because I don't want to find out that it's not inside UE5. I want to make sure that I fix it inside Maya before I get to go back to Maya and refix it later. So everything is working, everything is properly aligned, and we have a few options where we could use these modular railing for the stairs. Let's go ahead and delete what we don't need. Actually, we don't no longer need this piece either, the floor and this one. So we have our stair railing. Let's finish it up by moving it back. Actually, it's going to be positioned right here eventually when we export in world origin, so we can export it. We're going to delete history on it. I am going to position it in the world origin right here, and I'm going to make sure that I freeze transformations. I'm going to modify freeze transformations, so the pivot point will be at the world origin. This is going to be important when we export, and I'll go through that again of why it's important and why I freeze transformations of objects at their pivot point in the world origin. But that's when we export. And last, let's rename it. It's going to be railing stairs. And I'm not going to give a variation number or a height number or anything like that. We're only going to have one of these. If I had more and different variations of it, then I would give some kind of identification of what type, or maybe what height or what width and so on. I would add it to the name. But in this case, we only have one, and I'm just going to keep it simple by naming it railing stairs. Let's delete railing straight. We don't need this. And we now have our third modular piece for the stairs. Now we're going to create an end cap to close up these railings when they come to an end, as well as connector pieces at 90 degree and 180 degree. First, let's create an end cap. I'm going to reintroduce these back into the world origin. It could be any of these. I'll do the 150. I'm going to duplicate it. So we are working on a duplicate and not on the original copy. And all I need to do is make sure that the mesh is snapped exactly where we were working on for the rest of the pieces. In this case, back in world origin, but it could be on any grid point really. And then I'm going to bridge these edges and these edges using a blend, so it's a curved geometry. And then we're going to delete this piece and leave with what we have. And that's going to be our end cap piece. There are other end cap pieces you can create by having the top curve and go all the way down to the ground, like a vertical piece, and then another connector piece here. So different variations for end caps. In our case, it's just going to be one single curve. But if you want to have variations, just keep the same principles in mind as we are creating for this and for everything else for all modular railings. So I'm going to select an edge, double click, and I need this ring right here. Then hold shift, double click on this edge to select the entire edge ring. Both of them are selected. Go to model and toolkit and bridge. Curve type, blend, and add divisions. In this case, it is folding onto itself. And whenever you bridge and it folds onto itself, you just need to change the direction source and target. So let's try direction source, and I'm going to change it to plus. Here we go, fixed it. Otherwise, maybe direct target if I need to change it to negative. In this case, it didn't work. So this one fixed it. And let's increase more divisions. Let's go to 15. The amount of divisions you add will be up to you, how much geometry and how much curvature and how smooth you want that curve to be. I think 15 looks pretty good. And this green material just simply implies there are no materials applied. It's missing a material. So I'm going to right click at an object level, right click on the mesh. Actually, let me come up here so you can see the menu. Right click on the mesh, go to assign existing material and choose the Lambert one. I'm going to hit Alt 5 so I can see without wireframe. And it looks like the faces are faceted instead of smooth or soft. So let me select the edges, and I'm going to select all these edges right here. On this new curve, hold shift, right click hold, soften harden edges, and choose soften edge. And now we fixed it. So that's our end cap piece right here. I can go ahead, select the faces, and actually let me make sure that I'm selecting the faces on this railing. And I'm going to delete everything we do not need. And we have our end cap piece. And our pivot point is right here on the bottom on the grid. And that's exactly where I want it. So I'll be able to use this piece for any of these end caps. So let me go ahead and position this one, snap to the grid, and it will close it off. And if I needed to use it on the other side, I just simply duplicate. Let me just move it over here and then rotate it 180 degrees in this case. Hold J, rotate 180 so it snaps, rotate, snap, and then snap it to the grid. You can see it will align perfectly. Like I said, you would just repeat the same thing if you wanted to create some different variations. Let me delete this. So just as a quick example, I'm going to make a duplicate of this end cap. Control D. Let's place it back in on the grid at our working area and at the world origin. So if I wanted different variations of this, I could actually take this because I know this railing works. This end cap piece works now. I could just delete the faces, maybe at a halfway point. And then choose these edges right here and just extrude them down, snapping them. And then when I have another piece, I could have an end cap that resembles something like this that goes down to the ground. And I would need another cylinder that's actually inside this geometry so you could close this off. So what I could do is duplicate this, just move it in. Let me delete the faces for everything. And then let me switch over to vertices so I can go ahead and snap these to the grid. And then select the vertices on this mesh and just push them in. So something like this. So I could have this end cap, if I combine it, that would be a different variation of an end cap. Something like that. And it would look really good. So this was just a quick way of introducing some variety if you wanted to. I'm not going to keep this. I'm going to delete it, and I actually don't need this. Let me come back to our end cap. Let's go to naming. Going to delete history on it, and this is going to be railing end cap. And we are done with our end cap. Next, let's create a connector piece where we can make a 90-degree turn. Let's use the 300 for this. I'm going to make a copy of it, duplicate, Control D. I'm going to snap it to our working area, add its pivot point, and in the world origin. Like I said, it can be anywhere as long as it's on the grid. And then we're going to need the floor as our guide to know exactly where we need to place this railing, another railing, to create the connector piece for 90 degrees. So I'm going to move the floor slightly over this geometry, over our railing right here, so we have a little bit of a gap. This is how the floor, or this is actually how the railing would be positioned on top of the floor, not overlapping where we have a gap right here where we can see underneath it. It will be positioned right on top of it, like so. So that's what I'm recreating with the floor. I'm going to duplicate the floor and move it over here. Then let's take the 300 and duplicate it again, and I'm going to rotate snap 90 degrees and position it right there. So essentially I am recreating an area, the position of these two railings next to each other, like so, so I can have enough space to bridge between these two to create the 90-degree connector piece. Because you will position these 300 pieces, these straight railings, inside UE5 like so, and then you will have a separate piece, a 90-degree connector piece that you will position to close up these gaps and make them seamless. So that's what I'm doing. I'm aligning and positioning these railings first to create this space. So let me see it from the top, like so. So 90 degrees right here would be perfect. So we have a gap here. Now let's go ahead and combine these two railings. These are going to be deleted, and in-between connector will be left behind. I'm combining these because I'm going to be bridging them, and you need these two pieces combined together in order to bridge. I'm going to select the edges right here in the corners. Hold Shift, add to a selection, select these edges, bridge, curve type, set to blend, increase divisions, and let's go up to 8. One piece done. Let's do the same thing for the bottom with 8 divisions so they match. Let me select these edges, hold Shift, select these edges. Now I'm going to bridge, blend, and 8 divisions. That's it. I just need to delete everything in between. The things we do not need, the faces we don't need. So I'm going to select these faces, delete them, select these faces, and delete them. Let's apply the Lambert material, right click, existing material, Lambert. Let me take a look at it with our wireframe, and they are faceted. So let me go to top view, and I'm going to select all the edges except for the corner edges, these right here. These are going to be hard edges. So I need to select everything in between, but not those edges right here. With everything selected, hold Shift, right click, hold, soften hard edges, soften edge. Done. Our pivot point for these needs to be right here on the bottom. Add that grid spot right below them. I'm going to hold down D, X, and middle mouse click and drag to snap it. Let's delete history, rename it. This is going to be Railing 90, and that's going to be the name of it, Railing 90. Now I just want to test. Let's go ahead and make a duplicate. Let me move this first. Over here, I'm going to make a duplicate of this. Now let's make another duplicate. So I already tested this, but now I want to really test it again to make sure that everything snaps and we can use our connector piece. So I'm simply going to position these two railings how I would in UE5. I would leave this gap in between them. If I needed to go straight, I would just continue duplicating it. But then with this, we have a connector piece for 90-degree turn. Let me make a duplicate, and I'm snapping. All of these are being snapped to the grid. Exactly how you are going to work in UE5. And it is working. I'm gonna remove wireframe unshaded to see if there's any gaps, and it is perfect. Smooth. So we now have our 90-degree connector piece that we will use to turn our railings. And the last piece of modular geometry we need is a 180 connector piece. I can actually use the 90-degree connector piece, duplicate it again, and then rotate 90 degrees like so, and then snap it to the grid right there. And I will have my 180-degree U-turn connector piece from two 90s. But let's create a 180 piece so it's a whole single unit instead of using two of these together. For this, we're gonna do the same thing. I need to introduce one of the straight railings. Let's do the 150. Control D, I'm gonna duplicate. Again, I wanna make sure I'm duplicating and not simply moving, and then because I'll be deleting the faces I'm not using to keep the new created geometry. So I'm gonna position this one right here on the grid. I'm gonna make a duplicate of it and position another one right here. I can either position them this close by and then create an added degree piece. Most likely I'll be using it. Actually, let me see, because I wanna make sure that two of these together will form the same distance. But I could introduce different varieties and different distances in how they are connected. But I actually want to keep kind of uniform size right now. So yeah, it'll be right here. So the railing, whenever it's duplicated on the same level, I'm going to move it 20 units over. 10, 20, right here. So this way I can create that 180 unit piece to U-turn. So instead of using 10 units, making it a little smaller, they'll have to be positioned at 20 units apart from each other. With both of these positioned, let's go ahead and combine them. And you probably already know the process. We just need to bridge these edges and these edges together, bridge them, curve type set to blend, and add divisions. Let's change the source to positive. Yep, that fixed it. Let me take a look how many segments or divisions I need to add. Let's go to 12. That should be pretty good, nice and smooth. And let's do the same thing. Edges. Select these edges and these. Let's bridge, blend, and 12. And set direction source, in this case, to negative. Actually, that's incorrect. Let's work with direction target. Set it to plus. Let's go to top view. I just want to check, make sure everything's correct. And then let's select the edges right now, the ones we need to smooth. I'm going to hold shift, right click, hold, soften, harden edge, soften edge. Go back to object mode. Let's fix the material. Right click, hold, assign existing material, Lambert. All right, we have our 180 piece. Let's delete everything else right here. These two 150 pieces. We are left with the geometry that we're going to keep. I am not moving this right now. It's important that I modify the pivot point to be right there below these two pieces, D, X, and snap it to the grid below. Now, this is a new piece, 180 piece. I'm gonna go ahead and delete history and name it. It's going to be a railing 180. And one last thing, of course, we gotta test this one more time. So actually, let's just move it. I'm gonna test the original piece right here. I'm gonna snap it to the grid, position it to one of the railings, and we can actually take now the existing stair railing and snap it to see if it fits and if it's seamless. Let's get rid of the Y-frame. Very nice. And looks like the railing for the staircase, it's faceted for the horizontal railings. So let's go ahead and fix that. I'm going to switch over to edge component mode, select these edges and these edges, shift, right click, hold, and soften those edges. So we have 3 railing pieces, 2 connector pieces, and an end cap. Let's go ahead and export everything and then import it into UE5 so we can test. And then we'll come back and we'll UV everything. I don't want to UV right now without doing a proper test of all these pieces inside Unreal Engine. And then once the geometry is locked down, everything works, then we'll come back and UV. We're going to keep the same names that we used for all these railings, and we're going to export every single one of these pieces as an FBX. To properly export, we need to move each piece at its pivot point to the world origin, right here to the 000 world space. And this is why I freeze transformations on each of these pieces when I'm working at the world origin. So you should do the same. So what this means, let me move these out of the way. So what this means is whenever you're working on the piece, you are usually working in the world origin where you create your primitives. And then once you modify your pivot point, let me go ahead and snap this. And then you're ready to work on another piece, you tend to move this piece out of the way. And then you work on another railing piece or another modular asset or any 3D mesh. However, before moving this off, what I do is I freeze transformations after positioning the pivot point in the world origin so I can always bring it back when I'm ready to export. It just makes things easier and faster when I need to export, especially when you need to constantly re-export after fixing some things or making changes. So you can see it already froze transformations and everything, so I can always bring it back by just simply typing in the translate on X, Y, and Z, all to 0. And it'll be brought back into the world origin at its pivot point. To freeze transformations, you simply select the mesh after positioning and modifying the pivot point, go into modify, freeze transformations, and it will zero everything out so you can bring it back. you have to export all your meshes at its pivot point from the world origin so it maintains the same position from Maya to UE5. So let's begin with this railing first. I'm going to copy the name because I'm going to keep the same name. And naming things in Maya just makes things easier for me to just copy the name and use the same exact name. To export, we're going to export a selection by going to File, Export Selection. And I'm going to make sure that I have files of type selected as FBX export. Settings for geometry, I'm going to have smoothing groups enabled, smooth mesh, and these are the only two options that I need. And then let's type in the file name we want to use, which is the same name as the name in Maya. So I'm just going to paste that. And next, I just need to select a folder where I want to export this FBX file for this specific mesh. And let's create a new folder in here, name it Exported Meshes. Let's go inside here. And this will be our location for all the meshes we export. And export selection. Now this is done. Let's do the same thing for every single piece. Now I'm just going to zero out all the translations, bring it back to the world origin, copy the name, export, paste. All the options are kept the same, export selection. And now I will do this very quickly for all the other pieces. So you can see how quickly this becomes once you've gotten the system down of freezing transformations, putting it back on the world origin, exporting, naming, just saves a lot of time. Let's go ahead and bring it back, copy the name. And on my tool shelf, I have export selection added. So I don't have to go to File, Export Selection. I have an icon right here, Export Selection already. Also speed things up. Let's do this one. And then we have one more. And I forgot to put it in the world origin. Putting things into world origin is extremely important. Otherwise, the pivot point will be in world origin while the mesh is going to be somewhere else in the world. And let me double check. And it looks like this one right here, it is not, the pivot point is not in world origin. So the mesh would be in the same place, but the pivot point would be moved to the world origin if I went ahead and used this. So I actually need to place it into the world origin at its pivot point. And now let me go ahead and freeze transformations one more time so I can always bring it back. And now let me export. And I'm just going to replace it. And then we have one more, which is the end cap. And now let me check the pivot point. Yep, that's correct. And let's export. And this is our last piece. All right, we've exported everything. Let's go ahead and test in UE5. Open your UE5 project and inside the content browser, select the folder where you want to start importing your assets into. I have a WOLD folder, and then inside this folder, I have WOLD tutorials. And this is where I'm going to import everything. And inside this folder, let's go ahead and organize it better. I'm going to create a new subfolder, right click and empty space, new folder, and let's name it Modular Railings. And then go inside this folder and I'm going to create another subfolder called Static Meshes. And then we'll have a materials folder, we'll have a textures folder, so we can organize our content better. No spaces, make sure you avoid spaces. If you need to use a separation, use underscore. And let's go inside this folder. This is where all the static meshes are going to go into. Navigate into the folder where you exported your FBX files. And then I'm going to take them all and I'm going to import everything together all at the same time. So it's quicker. And I'm going to show you the settings you need to use. So I'm going to left click, hold and drag and just drop them into this folder to import. When the menu pops up, here are the options we want. We're going to reset everything to default. First thing is I do want to build nanites, so I'm going to keep this enabled. You can always disable it if you need it, and that can be done per static mesh. I do want to generate missing collisions. We're going to work on collisions and tweak them and adjust them, but I do want to generate missing collisions because we're not going to create collisions inside Maya. We're going to let UE5 create them for us. So I'm going to go ahead and keep that on as well. Then scrolling down, generate line map UVs. If you are going to use these meshes with baked lighting, you either let UE5 generate them for you from your UVs that you will do later. It simply takes your original UV channel, makes a copy of it, and then creates a light map channel to use for light map UVs for baked lighting. If you're not going to use these meshes with baked lighting, then you may want to disable it. And I'm going to keep the generate light map UVs on. And again, we'll deal with UVs later. And then the last option I want to have, which I like to use, is material import method. I want to create a new material, which will be a very basic shader, and it's going to be with an albedo color that's going to be off-white, and we'll apply that material onto all our meshes. So instead of using this grid world texture by default, it makes things easier to look at and easier to use prior to having any materials and textures imported and used. And I'll show you what this means. So I'm going to keep this on, and then I'm going to import all. All these options are going to be applied for all the meshes that we import. Let's go ahead and import all. And here we are. You can see that I created a Lambert material, which was the name of the material applied inside Maya. And if I open this up, it simply is a constant vector with an off-white color plugged into base color, and that's it. Very simple. And then that material has been applied to all these meshes, as you can see right here, and we'll end up replacing it when we have our own material. But instead of using this world grid texture, it's a lot easier to look when you have this off-white Lambert on all the meshes. All right, let's go ahead and drag all these into the level. And this is where you want to stress test and use them, duplicate them, and start creating some kind of a layout so you can test to see how your modular railings look. See if they snap, see if there's any problems, see if there's any gaps, and just drag all of these into your level. See how the end caps work. Basically, you are stress testing and seeing how everything works inside UE5 and if there's any problems. And if there are, you'll go back to Maya and you fix it. Maybe the pivot points were wrong. Maybe you have gaps in your geometry. Maybe you exported from a wrong location at its pivot point. But essentially here, this is where you stress test. So let me just quickly combine a few things together. I already stress test them, so I know they all work. But this is where you do it yourself and make sure that everything works for you. Let's do one more. Let's do 150 piece. See if we can create a little connection piece here. And let's try this one right here. Yep, everything works. Now for the railing, we do not have a set of stairs that we can test this on. So we would have to export those stairs that we created out of Maya and test them in UE5. So we can go ahead and place these railings so we can see how they actually work with a set of stairs. Because these are very specific to a set of stairs that we created these railings for. Let me jump back over to Maya really quick. Here are the stairs that we used. I'm going to modify the pivot point to be right here in the corner. Snap it to the world origin. And let's just export them as they are. Let me name it stairs underscore 150. Export selection. And I'm going to export it into the same folder, same options. These are going to be our test stairs. Stairs underscore 150, same name. Export selection. And then let me drag it into the same folder. Same options as for the railing. And let me drag the stairs right here. So the railings at that pivot point need to be right here in the corner. So let me go ahead and select everything. And then I need to drag this up. It needs to be on the ground. And needs to be right there in the corner. And I'm essentially looking at this piece right here. So it only needs to be raised up like so. So the railing needs to be flush with the third step. And let me drag this piece out of the way. So the corner of the railings need to align with the stairs right here. So they're modular. And then we have an end cap that we can go ahead and close that off. Yep, so that works. So we've did a quick test. The railings work, everything else works. And now we are ready to UV everything. And then we'll re-import everything with updated UVs, because at the moment the UVs on these meshes are all wrong. And we can take a look at it by double clicking on the mesh to open up the static mesh editor and go into UVs. Let's take a look at UV channel 0. Here are the UVs. We essentially didn't do any UVs. It kept the default UVs from the cylinders. You also have a second UV channel, and this is the light map UV channel that Unreal Engine created for you. We're not going to deal with the UV channel 1. We just simply created it, and we have light map channel if we need it for backlighting. We're only going to focus on the texture channel, which is UV channel 0. And that's our goal now. We need to UV all the railings. Let's go ahead and UV. First thing is we need to figure out what is the textile density we want to set for these modular railings. I'm not going to go too far into textile density and explanation, but I am going to tell you what we're going to use and how to set it up. So I want the UVs for these railings to occupy a certain amount of space inside the UV layout, inside the 0 to 1 space, so they look good and the texture resolution is correct and it's to the proper scale inside UE5. So to figure this out, I am going to use a 1K texture, 1024 by 1024, for 1 meter of geometry. And then once I know that value, that textile density, I'll be able to resize these UV shells for all the railings to match to that point of reference. And the textile density value is going to be found right here on the transform, and it's going to be used right here, textile density pixels units. So to find that number, and then we can use that number, this textile density number for everything else, I'm going to create a plane. Simple plane, and let me move this off to the side very quick. And I want to set this plane to width and height at 100, which is 1 meter or 100 centimeters. And I'm going to set subdivisions width and height to 1. So it's a simple plane. So this plane right here is 1 meter by 1 meter. And at the moment, the UVs occupy 0 to 1, the full space of the UV layout. So I want a 1K texture, 1024 by 1024, that would be able to fit into 1 meter of geometry and occupy its entire UV space. this is a good resolution to go with. So to get that textile density number, here's my plane. It's already occupying 0 to 1 space. And on the textile density, I'm going to tap in the map size that I want to use, would be 1024. Then I'm going to select the UVs and I'm going to click get. This will produce a number. So let me just change it to something else. So by selecting the UVs, if I click get, it tells me the textile density number for this map size of this UV shell. And this is the value that I can use to select any other UV shell and then click set to make every UV shell match this textile density number. And that UV shell will be resized to the proper scale and to this textile density. So let me go ahead and close this and I'm going to delete this plane. Let's go ahead and UV. The UV in these is very simple. It's cylindrical objects and I've already deleted the faces on the end caps, so it's going to make it a little simpler and a little quicker. I'm only going to do a few of these and then I'll speed up the entire process by just repeating the same steps. So let's UV the 300 railing first. Let me switch to the UV editing workspace and I'm going to go to face component mode. And actually, let's go ahead and project everything for this entire mesh and plane the project on Z. Just kind of get the UVs sorted inside the UV layout. Also, a quick note, I am going to utilize one single texture, a tile texture, that's going to be applied for all of these meshes. And our UVs can overlap and be on top of each other since we're going to utilize a tile texture, a single tile texture. So let's go ahead and take this railing and I'm going to project it. I'm going to scroll down to create, and with the mesh at the object level selected, I'm simply going to plane the project on Z. You could also go to create and plane the project by going to the options box and choosing which axis you want to project. There are shortcut keys. Middle mouse click, project on Y. Right mouse button will project on Z. And left click will project on X, which is what you saw set in defaults. So that's what I use. So once we project it, all I need to do is select an edge where I want to have a UV seam. So I'm going to select this edge right here. It's a single edge, so I don't need to double click to select a continuous edge loop. And I'm simply going to hold shift, right click hold inside the UV editor and make a cut. And then I will simply select this entire UV shell or all the UVs, and under unfold, I will run unfold. And then I'm going to simply straighten this UV shell by selecting a single edge, a straight edge, hold shift, right click hold, orient shells to edges. And this will straighten my UVs or the entire UV shell. And then in order to make sure that this shell is at the proper textile density that we set, I'm going to select all the UVs or the entire UV shell. And then under textile density, this is the number we're using. I'm going to click set. And as you can see, the textile density made our shell bigger, but this is the correct size for this UV shell due to our textile density we're using. So because we're using a tile and texture, the UVs can be expanded and be outside 0 to 1 space. And it will simply repeat that texture for the rest of the UV shell as it extends outside that 0 to 1 space. And now I'm just simply going to place this UV shell right here and continue for the rest of the UVs. So I'm going to continue selecting a single edge, making a cut, selecting the UVs, and then running unfold. Then selecting a single edge, orient shell to edges, select the UVs or the UV shell, and then set the same textile density for this piece, and then position it. Again, it can be overlap, or it can be right below it. It doesn't really matter, since we are going to be using the tile and texture. And then repeat for the vertical railings. Select where you want to have a UV seam. It's going to be barely noticeable unless you have some specific detail in there, specific texture. This is going to be all chrome, all metal, so those seams are going to be barely noticeable. Actually, let's select both of these edges. So we do them together at the same time. I'm going to make a cut, select the UVs, unfold, then orient shells to edges so the shells are straight. These I'm going to keep vertical just like they are on the geometry. And then select all the UVs and set the same textile density. So this is it. We've UV'd our first piece. And then I'm going to repeat the same steps for everything else. Let's do one more, which is going to be this right here. And then I'm going to pause the video and I'm going to UV everything else. But the steps do not change for any of these. You're just simply repeating exactly what you saw me do. So let's do one more, this end cap. I'm going to select at object level, or I can select the faces, all the faces on this mesh. And I'm going to plane a project. Again, in this case, I'm going to plane a project on Z, just to get the UVs inside. Not this way, but this way, so I can see the shape of the mesh. Then I need to select an edge where I want my UV seams. It's going to be right here. Double click on a single edge to select the entire edge loop when I make a cut. And once I made that cut, it will unfold properly. Select all the UVs, unfold, select the single edge and orient shelves to edges. And then let's set our textile density and position it somewhere inside 0 to 1 space. Like I said, for all these pieces, let me select both of these, they can overlap for their UVs because one single texture will be applied for all of them, for all these pieces. So I'm gonna pause the video and in just a brief second, all the UVs will be done. All right, UVs are done. And here's what they look like inside the UV space. Everything matches in textile density. I kind of repositioned some of the UV shells to spread out a little bit more. And now we need to re-export everything and then re-import so we update the UVs of these meshes. Now that you know how to export, you simply have to reposition your meshes back in world origin by zeroing out the translations if you've frozen transformations there. And I'm simply going to copy the name, export selection, go back into the same folder, paste the name, export selection, and overwrite to replace an existing file, the existing FBX we exported earlier. And just simply do this for all the meshes so you have updated, clean UVs for them all. Then back in UE5, to re-import updated meshes with new UVs is extremely simple, and it will update all your meshes, including the ones you've already placed inside the level. Simply right-click on the mesh and re-import. And the mesh will be re-imported. So I'm going to select all of them instead of doing them one by one. Right-click and choose re-import. Done. Now let me just take a look at one of them, just so I can check on the UVs. Your texture and UVs are going to be found inside UV channel 0. And here are the UVs. So the UVs are done. Our next step is to create the texture. And we're going to use Substance Painter. I'm going to break down how to create a tile and texture for our modular railings. This portion is going to be very simple because the texture itself is very simple. So let me talk through what I have and how to create one. Here is a scene I have set up with a tile and plane. This is a plane that contains 9 quads. And each of these faces is UV'd to occupy 0 to 1 space, and every single one of these is on top of each other. This helps me to test tiling and repetition of textures. So whatever you see in any of these quads will repeat for all these polygons that you see, for all of these squares, thus telling me how the texture will repeat and tile. And this plane is also the same one that's being used for the floor. So this way I can see how the floor will look or how the wall will look and how those textures will repeat themselves. I have a tutorial on how I set this up if you want to have one of these yourself. And then I also have a UE5 mannequin inside the scene to help me judge scale and dimensions of the texture size. So I get the scale of the tile and textures or any textures correct. And this helps me a lot, especially for tile and textures. And we do not need to bring in modular railings into the scene to texture. We just need to create a tile and texture to export. Since all the UVs are on top of each other and they're using the same texture, we actually don't need to be texturing that asset by looking at it inside Substance Painter. And the scene has everything we need. So next you would just search for some kind of a metal material to apply to this plane. There are a few here by default, such as metal brushed might be pretty good. So you simply drag and drop them onto these planes, tweak the settings in order to see the tile and texture. So by default, you're not going to see the wireframe, and it just helps me to know where that scene would be and how it's going to tile and repeat. You can enable this wireframe by going to settings, scroll all the way down and enable wireframe and then choose the color. So you can see the texture is going to tile seamlessly. If you don't like this specific material, delete it, apply a new one, tweak the settings and see if that's the one you want to use. I downloaded a chrome material and I already have it applied right here. So this material is available in Adobe Marketplace as part of your Substance Painter subscription. So I downloaded this Chrome, I applied it, and this is the one that I'm going to use. Again, I already tweaked some of these settings in order to make it look how I want it. Change the roughness. There's a dirt parameter here. There are scratches if you want to apply some scratches, scratch intensity and so on. There's quite a few good settings here for this chrome metal, and as well as I change color. So this is the final tile and texture that I'm going to export. It looks pretty good and it's going to look great on the modular railings. Again, it's very simple. There's nothing more I'm going to add to this. And next step is to export this as our PNG textures to using UE5. And for this, I simply went to File, Export. And one thing that you want to do is make sure that you name the texture set list, because this is going to be part of the name of the file of the textures. So I named mine metal_chrome. And this is the one we're going to export. Not the mannequin. Mannequin is the human scale reference I have in the scene. So it's this one right here. Then you go to File, Export Textures, choose an output template. In my case, I have Unreal Engine 4 Packed Custom. It simply removes some of the names, but the default one that you want to use is Unreal Engine 4 Packed. The textures will be saved as PNG, 8-bit. The size is based on texture set size. I actually want to change it to 1K. And this setting right here, based on texture set size, it comes from what you were working on inside the viewport, which was 2K. So I'm going to change it to 1K. Everything else at default. I want to make sure that my metal chrome texture set is selected and then choose the output directory. So I'm going to click on this and find the location to save these textures to. And here I navigate into the folder and I'm going to choose select folder. So my textures are going to be found right here. And then I'm going to click on metal chrome texture set list and just take a look at what's going to be exported. We're going to have a base color, we're going to have metallic, roughness, and ambient occlusion packed into a single texture. And actually we're not going to have any ambient occlusion, but we will have roughness and we will have metallic that we can use from this one single texture. Then we'll have a normal map and we will not have emissive because we don't have any emissive properties on our material. So it's not going to actually create an emissive texture, even though it's checked. And with that, click export. And our textures are done. And here they are. Here's the base color, here's the normal map, and here's the packed texture, the roughness, metallic, and ambient occlusion. Let's go ahead and import our textures into UE5 and then set up a material. Go ahead and take your textures and then create a subfolder for better organization. Let me go to Modular Railings, and inside here I'm going to create a new subfolder and name it textures. Let's go inside this folder and I'm gonna left click, hold and drag these 3 textures into this folder. The only thing you need to make sure to do is take your ambient occlusion, roughness and metallic, double click on it to open up the texture editor and disable sRGB. This texture needs to be in linear space since we're going to be using individual channels from it, and then save it. And that's it, that's all we need to do. Let's create a material. I'm gonna create a new subfolder inside our main folder and name it materials. Let's go inside here and I'm gonna right click in the empty space and create a new material. Let's name it M underscore for material, metal, chrome. And let's open it up. And let me dock it. I'm gonna take those 3 textures, select them all, left click, hold and drag and drop them into our material editor. And let's connect these up. So the base color will go into the base color input. Then we have our normal map. Let me drag this down. RGB goes into the normal map input. And then we have our packed texture. The only thing we need out of here is the roughness and the metallic property. So you have RGB. Red channel is ambient occlusion. Green channel is the roughness. Blue channel is your metallic. Acronym I like to use is ARM. A-R-M. So A stands for ambient occlusion. R stands for roughness. Let's go ahead and plug that in. And M, or blue channel, stands for metallic. And that's it, that's our metal right here. And I am not going to go through and try to set up anything more. If you are familiar with a material editor and how to set up different parameters so you can expose them inside the material instance, such as changing color, maybe adjusting roughness and so on, I suggest you do that. And if you want to know how, I have a tutorial course, Master Material Creation, that will show you everything you need to know. And I go into depth on how to create your own master material. In our case, this is all I'm going to have. Just keeping it simple for this video. But I would set up many more functions in here to make this material more versatile and adjustable. Go ahead and save this. That's it. We can close this down. And let's grab this material and then begin to apply to our railings. So I don't want to drag and drop them inside the level onto the railing. I actually want to apply this material globally to every single instance of these meshes being used inside the level. Not just the ones placed, but the future ones that will also be used. So I need to go to static meshes folder, select all of the meshes and open them up inside the static mesh editor. So I'm going to select them all and hit enter. And this will open up static mesh editor for each of these. And let me drag this out of the way because I need to grab the material and drop it into this material slot, replacing the Lambert one with our existing material. If I had a material instance, I would actually use that instead of the material itself. But since I'm not going to create a material instance, I'm dragging the material. And just taking a look, you can see we have nice chrome finish, clean metal on these modular railings. Then simply go up and save this asset. Close it, and then do the same thing for every single modular railing you have. Replace the material, and then save it. So I'm gonna do this very quick. Save it. We have 3 more. Here's the rail and 90, the connector piece. And then the stairs, actually, I don't want to use this to apply this chrome. So actually, I'm going to close this down. And now all the materials get updated inside the level. And I can take a look, see how they actually look inside the level with the lighting. And it looks very nice. So we have our textures done. It's a talent texture. You can see every single one of these railings are now using it. And we created a material and applied it to our meshes. And now for the last step, we need to create our collisions. So we have default collisions that UE5 created for these assets on import, but they're going to need some adjustments. So let's go ahead into the static mesh folder and open up all the meshes, all the 5 modular railings. I'm gonna select them all, hit enter, and open it up in static mesh editor. So let's take a look at this one first, the 300 straight. To show collisions, go to show and enable simple collisions. These are the collisions that UE5 created on import. And we could use these, but we want to be more precise. We actually want to have collisions where the railings are. So to make that adjustment, I'm going to use convex decomposition right here. And then we're going to recalculate everything. If you need to delete any of these collisions, through convex decomposition, it will remove the previous one and apply a new one. But if you need to delete everything, you could by going to collisions and remove collisions. If you don't see this box, this convex decomposition, go to collision and enable auto convex collision. So let's go ahead and run the default settings and see what it comes up. Just simply hit apply and look at the result. So this is actually not bad, but we're gonna need a little bit more precision. So we can increase the hole count. This is the amount of collision holes it will create. So right now we have 4. So we have 1, 2, 3, 4. If we need more, we can input here. Then we can adjust max hole verts, how many vertices each hole collision will have, and then we can adjust hole precision. And I want to be more precise, so I'm going to increase hole precision. So let's go higher. Let's go to 300,000 and hit apply. A little bit better. Let's increase the precision maybe to 500,000. And if we want to tweak further, which we should, let's go ahead and I'm going to increase the amount of hole count. So let's say maybe I increase it to 6, see what kind of results it gives me. And this is much better. So our collisions now look a lot better and they're more precise. And you can continue tweaking this with different settings. Hit and reapply will remove the previous one and apply a new one. And you can just kind of go through and tweak it to exactly what you need. So I actually like this better. So I'm going to keep it. Once your collisions are done, simply save it, close it, and continue on to the next one. Let's enable so we can see it. Go to show, simple collisions, and let's run the default settings, see what it does. And the default settings worked perfectly for this. Let's hit save and move on to the next. For this one, I'll probably need to increase the precision, maybe the hole counts. Let's turn on the collision first. Yeah, this is not very good. So let's do the default settings first. All right, I'm going to increase the hole count. Let's go to 6 and the precision to 500,000. And this is much better. Let's go higher. Let's go to 8. This one will probably have the most amount of hole collisions. And maybe let's increase the vert size. Let's go to 24. Again, better, but still need some work. Let's do one more time. Let's go to 10. Let's bring it back down to 16 for hole verts. All right, we're getting there. Probably do one more. Maybe let's increase to 600,000. And here we are, much better. Let's go ahead, save. So you can see how quickly you can create collisions without having to create your own custom collisions out of Maya, which you could, but since we have this capability inside UE5, we might as well use it. And if you need something a little more specific, maybe less amount of holes, and you just want to have full control over your collision holes and how you create them, then you should create them inside Maya and then export them along with your mesh. But that's for another tutorial and for another how-to. So that's all you do. Just go through and create your collisions. So for this one, default is perfect. Moving on to the next one. Let's do the default, see if it creates good results. You can probably be a little bit more precise. Let's go to 8. Let me bring it back down to 6, see what that does. And that's pretty good. I think 8 was better. Done. And one more. For this one, probably 4 should work. Yep, done. Save them all. And now we are done with collisions. And actually, we are now done with our modular railings. And all there is left to do is simply begin to use them inside your level and create your modular railings. So I hope you enjoyed this entire tutorial, this entire pipeline from beginning to end, and I will see you in the next one.